In this video, I'm going to show you how to add and subtract rational expressions. Rational expressions are really just fractions, except they have polynomials in the numerator and denominator as opposed to simply just constants. However, the same general rules apply. So let's look at this example here. Let's add 2/9 and 4/15. In order to do that, in order to add fractions, you need to have a common denominator. And the preferable situation, in order to keep it as simple as possible, is to have the least common denominator. So the way that we're going to do that is to find the least common multiple of the denominator. They call this the least common denominator, or the LCD. The way that you go about finding a least common multiple is by factoring things into their smallest components, into their prime numbers. So in this case, since we don't have any variables, we can simply look at the numbers in the denominator and find what it factors down to. So this first expression we have, 9, factors down into 3 times 3, or 3 squared. So we're going to put that 2 over 3 squared in the denominator. On this side, 15 factors down to 3 times 5, so we'll write that as 4 over 3 times 5. Whenever we're finding a least common multiple, we look at all the different factors present. So in this case, we have a 3, and we have 5. And we take the highest power of all of those factors present. So of the 3's, we're going to end up with a 3 squared, and of the 5's, we're just going to end up with a 5. Once we have that, we need to make sure that we multiply each fraction by whatever it needs to be multiplied by in order to get that common denominator. In this case, we said 3 squared times 5. So let's go ahead and do that. First one, in order to get 3 squared times 5 in the denominator, you need to multiply top and bottom by 5. So we do that. Now our denominator is the least common denominator, which is exactly what we want. And our numerator has changed because we don't want to actually change the expression. We just want to cleverly manipulate it in order to be able to do the addition. So we have that. On the other expression here, we have the 5 present, we have a 3 present, but not 3 squared. So we multiply top and bottom by 3 in order to get our least common denominator over there. If we do that, because we multiply the denominator by 3, we multiply the numerator by 3, and that changes our expression. Now, since we have the same denominator in both fractions, we can write this all on one line with the same denominator and simplify in the process. So 2 times 5 is 10, 4 times 3 is 12. We write this all on the same line with one common denominator of 3 squared times 5. Of course, you add the top and you simplify and you get 22 over 3 squared times 5. Now, if this was a normal problem with just numbers, you would probably simplify this farther to get 45 in your denominator, but just to prove a point for what we're going to be doing, it would be something similar to this. It might be a squared b in your denominator. So let's take a look at some of those more complicated expressions. In this problem, we have 5a squared over 6b plus 9 over 14a squared b squared. We need to find our common denominator because we can't add these without a common denominator. And in order to do that, we factor each denominator as far as it can go. So let's look at 6b first. We know that 6 goes down to 3 times 2, so let's do that. We'll write that as 3 times 2 in the denominator. And we, of course, leave our b. On the right side here, 14 factors into 7 times 2, and then we leave our a squared and b squared there. And 7 times 2 down here. And now we're looking for what is our least common denominator. So what factors do we have present? We have a 2 in both. We have a 3 only in one of them. We have a b in both. And an a. And actually we also have a 7. Highest power of all of these, I'm going to go ahead and look at this. Our 2 is taken to the first power, so that's the highest power we can get. Our 3, also taken to the first power, is the highest power present. We have a 7, again, highest power is 1 in this problem. Wrong color. There we go. Our A, highest power is 2. So again, not very much overlap in this particular one. B is our only overlap, in fact. We have a B and a B squared. The B squared has a higher power, so that's going to trump and get in our least common denominator. Now, in order to get our least common denominator on both sides, we need to figure out what we need to multiply by. So we have the 2 already, we have the 3 already. We don't have a 7 or an A squared, and our B, we're missing one of the B's. So we need to multiply top and bottom by 7A squared B, because that's what we're going to need to get to that least common denominator. So, since we don't want to change it, clever form of 1, 7A squared B on top and bottom. On the right side here, we have the 2 present, we're missing the 3, so we need to multiply top and bottom by 3. A squared we have, 7 we have, and B squared we have. So we really just need to multiply top and bottom by 3. So this one's a little bit simpler to work with. Now, since we have a common denominator on both sides, we just simply write our new numerator and our new numerator on the other side all over one least common denominator. So that numerator is going to be, if we multiply 5a times 7a squared b, 5 times 7, 35, a times a squared is should be a cubed. Got that fixed. And on the right side, 9 times 3 is simply 27. All that's over our common denominator. Now we can't really simplify or cancel anything out here. There's nothing in common on the numerator and denominator all the way across. So we simply multiply out our denominator, the constants there, to get it to our final answer of 35 a cubed b plus 27 all over, this multiplies to 42 a squared b squared. On the right side here, we have x plus 10 over 3x minus 15, all minus 3x plus 15 over 6x minus 30. So let's see what we can factor out of these denominators. On this side, I know that we have a 3 in common between 3x and negative 15, so we'll factor that out, and we'll have an x minus 5 times 3. X plus 10 stays in our numerator. On the right side here, we have 6x minus 30. I know I have a 6 in common with both, so I'll pull out the 6. But remember, since we're factoring, it's going to be not only just 6, but 3 times 2, and then an x minus 5 will be left over. And then we keep our numerator as is. We need to find our least common denominator. I see a 3 in both. I see an x minus 5 in both. And I see a 2 over here. So it looks like highest power of any of these is 1, and the only one that is missing is a 2 over here. But our least common denominator is actually the same as the denominator on the right. So that means we won't actually have to do any extra work to change this. However, on the left side we will. So let's go ahead and do that. Multiply top and bottom by 2 so that it gets up to our least common denominator. Of course, multiplying, clever form of 1 here. And the right side won't need to make any changes because it's just fine the way it is. The big step now is to pull it all onto one line, and remember that there's a minus sign in front of this entire fraction, which means effectively that it is being applied to this whole side. So I'm just going to throw those in parentheses, because being over a fraction bar implies that everything is in parentheses. So we need to be careful when we write that. Since we know what our denominator is going to be, let's go ahead and work across for our numerator. We still have 2 times this grouping here. And on this side we have the negative sign applied to that entire group. Don't forget the parentheses here, this can really burn you. Once we're at this point, it's simply distributing and simplifying all the way through. We see that we have a 2 that can distribute here, and on this side we have a negative sign that can be distributed to both the 3x and the 15. Our denominator won't change. So let's work across. 2 times x, 2x. 2 times 10 is 20. We have a negative 3x and a negative 15. Next up here, let's combine our like terms. We have a 2x and a negative 3x. So that's going to combine to negative x. And a 20 and a negative 15 will just simply add up to 5. So we're going to have 5 and a negative x. So 5 minus x, or you could write negative x plus 5, same thing. In our denominator, we have still the same thing, 2 times 3 times x minus 5. Now, you may remember the clever multiplying by a negative 1 to flip the order of something. So if we do that, if we multiply by a negative 1, we can flip the order of these two and be able to cancel them out. So let's do that. Sorry, the work was not shown here, but if we take this and apply the negative inside and apply the negative 1 outside, we're effectively causing no net change to the equation. And now we can cross these two out. So it'll simplify down to negative 1 over 2 times 3, which we know is going to be negative 1/6. Final two examples, if you are still looking for a little bit of extra help here. We have 3x squared over 2y plus 5 over 12x y squared. First thing we do is factor things out in the denominator. 2 and y are as simple as they're going to get. 12xy squared, 12 goes down to 4 times 3, or 2 times 2 times 3. So we'll write that as 2 squared 3xy squared. We have 2's present, we have y's present, we have a 3, and we have an x. So all those need to show up in our least common denominator. And thus they do here. Highest power of the 2's was the 2 squared, so we keep that. Highest power of the y's was the y squared, we keep that. And the 3 and the x each were to the first power. So now we need to see what we need to change to get everything to our least common denominator. Looks like the fraction on the right matches it exactly, so we won't have to do any work there, but on the left, we need to multiply by a 2, a 3, an x, and a y in order to make it in common with the right side. Let's go ahead and do that. 2, a 3, an x, and a y. Multiplied on top and on bottom, so we're causing no net change to the equation. And our right side we can just leave alone as is. We now know that our denominator is going to be our common denominator, and we can write everything over one fraction bar. And here we just need to multiply out our numerator. So we're going to have 3 times 3 times 2. 3 times 3 is 9, times 2 is 18. We have an x squared times x, so that's going to be x cubed. And then we have a y. Plus, on the other side, we still have our 5. Don't forget about the other fraction while you're simplifying. From here, we can't really cancel anything out anymore, so let's just multiply the numbers in our denominator. 2 squared is 4, times 3 is 12. And we're going to get a final answer of 18x cubed y plus 5 all over 12xy squared. Final example here. We have a very complex fraction with addition and subtraction going on in the fraction. Pretty messy. Before we can actually do the division to simplify this down, you're going to want to get a common denominator in both your numerator and your denominator of the complicated fraction that we have in front of us here. So let's get started. We know that the factors present in our denominators up here, a and b, we have a to the first and a b to the first, so to get them both up to code, we need to multiply top and bottom of this by b, top and bottom of this by a. And go ahead and do that. This is just writing this as 1 over 1, so it's a little easier to see. Top and bottom by B, top and bottom by A. And in the denominator, we need to get a common denominator of B for both. So we know that this -1 could be written as B over B, because the 1 doesn't really count as a factor. So multiply both top and bottom by B over B here. We're almost treating these as two separate problems that happen to be going on at the same time with a big bar in the middle. So don't try to confuse the fact that there's B's down here and B's up here. That just happened to work out that way because of the way the problem was written. But whenever you have something like this, solve each of these independently as far as you can, and then we'll worry about combining it together into one big fraction or division problem. So on top, we have a common denominator of AB. On the left side, we have 1 times B is B, and plus 1 times A is going to be A. So B plus A over that common denominator of AB. Down below, we have a common denominator of B, because B and B times 1 are the same. And we have 1 minus 1 times B. So 1 minus B all over B. Once you get it this far, now it's a division problem that you can handle. Because now you can solve this by cross-multiplying, or by multiplying by the inverse, because remember, division of fractions is multiplying by the inverse. So we're going to take this fraction up here, and we're going to multiply it by the inverse of the fraction down here. So B plus A over AB, all times B over 1 minus B. Once again, we are not adding or subtracting here, so don't try to get yourself a common denominator. Just straight up multiply all the way across. And so on top, B times B plus A is simply going to be B times B plus A. Same idea in the denominator, AB times 1 minus B. So now we've got one expression. We can start to cancel things out in common. See that we have a B on top and on bottom. Let's get rid of that right away. And I believe that's all we can do. So once we cancel those two out, we're going to be left with a final answer of B plus A over A times 1 minus B. We started out with this very messy expression here. By the time you boil it down, simplify it, get yourself common denominators, multiply by the inverse, cross out anything that you have in common, you're going to get yourself B plus A all over A times quantity 1 minus B.